So plotting the graph of the gradient function, we're going to be plotting x against the gradient. So the y-axis is going to be the gradient. So any gradients that are positive will be above the x-axis, negative will be below. If the gradient is 0, then that's going to appear on the x-axis. So we're trying to find out the behavior of the gradient for the x value. So if we look here, we got 3 turning points here, here, and here. So therefore, they're going to be the x-intercepts. So you can mark them first, here, here, and here. That's where it's going to, the gradient function will have its x-intercepts, notating that there's a 0 gradient. This section here, we've got negative gradient. So that means this section is going to appear below the axis. And it's going to become less and less negative as you go towards the turning point. And this section here is going to be a positive gradient, therefore it will appear above the axis. And the gradient's getting steeper and steeper until halfway between the 2 turning points, where it starts to ease off towards 0 again as it reaches the turning point. So expect it to come down like this. There's a negative gradient here, and the same will happen. It will become more and more negative, so it will appear below the axis till halfway, and then it'll start to ease off towards 0 again as we hit the turning point, where you'll have another x-intercept. And then in this section here it's positive, and as we go from left to right in this section, the gradient's getting steeper and steeper, so we'll go up. So looking at this graph, you should identify that as a positive quartic, so therefore when you find the derivative of a positive quartic, it's going to be a positive cubic. Alright, so we'll just run this now and see what the gradient graph looks like. So you'll see the value of the gradient here. So here, the turning point, that's why we're going through here. Maximum gradient here is halfway between, and then it will come back down and going through at the next turning point. And then again, halfway between, you reach a maximum negative gradient, so the minimum gradient here, and then up again.